Hi everyone, I'm Alberto Ortiz, and in this video I am going to show you my IBM Capstone project. In this video I will introduce my own dataset which contains two fields with similar names and other fields that I will not show you for privacy. Okay? The user cases, the first is to find the similarity between the names in the entire dataset and to duplicate them. Once the previous step is finished, create a list with unique names, right? Here I show the CRISP ML methodology, and here I will focus on the level of the data preparation, which in my opinion is the most important step within the LAXO data science project. Why? Because if your data does not they are clean, the model will not perform well. Remember, trash in, trash out. Okay? Within the level of data preparation is a data cleaning field within which different steps are performed, such as anomaly detection, handling noise, and duplicate information as a special activity in this video. Here I shown a hypothetical case of a relational database with some tables like the user table, that contains attributes like the ID, the username, and gender. The other table is the purchases. It contains the purchase ID, the username, and the user ID. These IDs have 40 key for the users table. And in database, there are more tables with which they are related. In the table, several inconsistencies in the name can be shown, such as Margarita and Maras Mantecon. That is, the purchase table is not his full last name. Another case is in the second with ID 130. Then in the table of users writing starting with the last names and then the name otherwise. And then the name. Otherwise, in the purchasing table, that the registration begins with the name and then with the last names. Right? This is a special case to the other because the names are in the same table. Although it may happen that they are two different people with the same name, or that is really the same person, but okay? To be sure they are not the same person, there are two options. We have two options to do. The first one is to ask the business person in the organization to tell us more information about this inconsistency in the database, in this table. Or the second, using our magic and knowledge, if we have access to more information within the organization, we can use it. The tools that can help us verify that it is not really the same person are, for example, the address, direction, the other is the cell phone, and if we are lucky to having the most important field that helps to identify that two people are different is the passport card in the case of the United States, which is unique for each person. If the identifier is different, then we ensure that two people are called the same. But in the case on the contrary, we can say that it is the same person and that his name was writing twice differently. Here I show a little exploration of the data and the different problems that names have. In the first row, a letter is replaced by a symbol. In the second record, the same is incomplete. In the third case, the name is spelled differently as I mentioned earlier. In the last example, only one letter in the middle name was placed. For, for all these cases, the computer at the time of comparing the two names will always say that they are different. Always this happen. In the data set I have 97% similar names and the rest of the record is not. Right? To deal with this kind of problem, we can use traditional methods to find the similarity between two strings or two names. Among the most popular methods are Levenstein, causing similarity, and n-grams. Unsupervised methods such as clustering can also be used. In this case, I use a deep learning method with a well-known neural network type, which is the LSTM model, and its formal name is LSTM Siamese Neural Network. Its architecture is composed of two LSTM neural networks. The first neural network has the first name as input, as the other neural network the second name. The output of each neural network will through a process of computer similarity, and that is the score of similarity between the two names. Okay? Now I am going to present you the development of the model in my Jupyter notebook. Here only I import the libraries. Here I define all the necessary methods for the data. Here I load the data and show some values with its label. In this part, I pass the necessary parameters for the neural network to train. I define ReLU as the activation function. For the training, I have 8,645 examples, and for the validation stage, 916 samples. As I shown, the model has a very good precision. In this part, we can see it. For the testing stage, I have the examples from the presentation. And as you can see, the score in similar names in this part. And as you can see, the score in similar names is very good. And for names that do not have similar, the score is very low. In conclusion, the Siamese neural network LSTM is a fantastic method for this kind of problem. You can use it to other kind of problems, like if you want to find the similarity between two sentences, or in sometimes between two or more questions. To finish, I would like to recommend the following article that talks about the LSTM Siamese neural network. And that's it. This is my my project. Thank you for watching and see you.